Welcome to this session. In this session, you are going to solve another initial value problem by matrix method. So we have the second order differential equation, d squared x dt squared minus 5 dx dt plus 6x equals to 0. And the initial conditions are x at 0 is 1, x prime at 0 is 2. So to use matrix method to solve this, first thing is to change this second order differential equation into a system of first order differential equations so that that system can be written in the form x dot equals to ax. And once you have done that one, then you write this initial condition in the form x of 0, and then below it x prime of 0. And then this can just be written as x of 0, which will be the same as x of 0 is 1, x prime at 0 is 2. So after getting the solution to this equation, you use this vector to find the values of the known C1 and C2 to get the specific solution to this problem. And then in your final step, the solution to the given differential equation will be the value you get in the first row, because the second row is the derivative of what you get in the first row. First row is the value of the function itself. Now, let's see how we do that. So solution, the first thing is to get x dot equals to ax. So we start by saying let x to be x1. So which means dx dt is equals to dx1 dt, and call this derivative another variable x2. Now call this one equation 1. Since d squared x dt squared will now be the same as d squared x1 dt squared, because we have already specified that x to be x1, and this can be written as d dt of dx1 dt. That's the definition of second derivative. Now, because we have already specified that the x1 dt is x2, so this is the same as dx2 dt. So from the differential equation given, we make this one the subject. Dx squared x dt squared is given by that's 5 dx dt, and then that will be minus 6x. But because we have said x1 is the same as x, so if I put here 1, I put here 1, I put here 1, there's no mistake. So it's telling me that dx squared x1 dt squared, which can be written as from this simplification, dx2 dt is the same as 5 dx1 dt is x2 from equation 1 minus 6 x1. Call this one equation 2. Now we have already the system of linear differential equations. So we have dx1 dt. This can be written as 0x1 plus x2 and dx2 dt is this, you rearrange it as minus 6x1 plus 5x2, from which we can write it as dx1 dt dx2 dt equals to, now in matrix form we have 0, 1, minus 6, 5, x1, x2. So this is what you are calling the x dot. This is the A matrix, and this is the x vector. So that now our A matrix is 0, 1, minus 6, 5. So let's get the eigenvalues. To get eigenvalues, you solve A minus lambda I determinant is 0, i.e. determinant of 0 minus lambda is minus lambda, 1 minus 6, 5 minus lambda. This will give us 0. And that will be minus lambda, 5 minus lambda, minus minus is plus 6 equals to 0. So we'll have lambda squared minus 5 lambda plus 6 equals to 0. This quadratic product is 6, sum minus 5, numbers minus 2, minus 3. So we'll have lambda squared minus 2 lambda minus 3 lambda plus 6 equals to 0. And then you pair. So lambda into lambda minus 2 minus 3 into lambda minus 2 equals to 0. So lambda minus 3 into lambda minus 2 is 0. And solving this gives you lambda 1 is 3 and lambda 2 is 2. So we have the eigenvalues of the matrix A. Immediately after eigenvalues, you get eigenvectors. Next, we find eigenvectors of A. So let's start with lambda 1 equals to 3. Now remember, we let this a 2 by 2 matrix, so let the eigenvector to be U1, whose elements are x1 and x2, or components are x1 and x2. So this is the equation that must be solved. Eigenvalue, eigenvector equation. So our A matrix is 0, 1, minus 6, 5 times U1 is x1, x2 equals to 3, which is the eigenvalue, x1, x2. And then we have x1, x2 minus 6x1 plus 5x2 will give us 3x1, 3x2. And for this equation to make sense, first row and the first row should be the same as, should be equal, and second row must also be equal. So this equation 1 and this equation 2. Check that equation 1 and equation 2, they're the same, because this means minus 6x1 equals to minus 2x2. So x2 is simply 3x1. So when we let x1 to be t, then x2 will be 3t. Remember, this t is any non-zero real number, because if it's 0, then we have a zero vector, which is not an eigenvector. So u1 will be x1, x2. x1 is t, x2 is 3t. So which you can write it as 1, 3, and then factor out t. So t is non-zero real number. And for convenience, we choose t to be 1. Then u1 will be the vector 1, 3. Now x1 of t is given by e raised power lambda 1 t u1. This is how we get the first solution. And this would be e raised power 3t. And then u1 is 1, 3. So that's okay. Quickly, let's solve for the second eigen vector. So lambda equals to 2. We'll have, let our eigenvector be u2, given by u1, u2. So we expect to solve the vector equation au2 equals to lambda 2 u2. So the matrix A is 0, 1, minus 6, and then 5. And then we have u1, u2, and then 2 into u1, u2. This, when you multiply, we get u2, and then minus 6 u1 plus 5 u2 equals to 2 u1, 2 u2. And for this equality to make sense, then u2 must be the same as 2 u1, and minus 6 u1 plus 5 u2 equals to 2 u2. This equation 1, this equation 2. Check that equation 2 and equation 1 are the same. So when we let u1 to be t, then u2 should be 2t, and this t is any non-zero real number. So therefore, the vector u2, which we have given as u1, u2, will be t, 2t. We factor out t, 1, 2, t. And when we pick t to be 1, then we'll pick our eigenvector as 1, 2. So therefore, second solution, x2 of t, is given by e lambda 2 t u2, which will be e raised power 2 t. u2 we have gotten as 1, 2. By superposition principle, we know that the solution to the differential equation or to the system is given by x of t is a linear combination of x1 of t and x2 of t. So this will be C1, x1 of t. We got our answer as e raised to power 3t, 1, 3. And x2, we have gotten our answer as e raised to power 2t times the vector 1, 2. So this is x of t. Remember, we were given the initial condition that x at 0 is 1 and x prime at 0 is 2. So this is what we write it as a vector x, capital X of 0 equals to 1, 2. And remember that first line shows the value of the function, second row shows the derivative of that function. So x of 0 is given by 1, 2, which will be given by C1 e raised power 3 times 0, 1, 3, plus C2 e raised power 2 times 0, 1, 2. 2 times 0 is 0, 3 times 0 is 0, e raised power 0 is always 1. So we'll have C1, 1, 3, plus C2, 1, 2, should give us 1, 2. So which tells us that C1 plus C2 and then C1 plus C2, 3C1 plus 2C2 should give us 1, 2. And so for this equality to make sense, C1 plus C2 should be 1, and 3C1 plus 2C2 should be 2. These are just simultaneous equations in C1 and C2. So if we call this one equation 1, call this one equation 2, then from 1, C1 is 1 minus C2. So we replace in the second equation where the C1 by this. So 3, 1 minus C2 plus 2C2 equals to 2. So 3 minus 3C2 plus 2C2 equals to 2. So 3 minus C2 equals to 2. So C2 equals to 3 minus 1, which is 3 minus 2, which is 1. And then C1 from here will be given by 1 minus C2, which is 1, equals to 0. So therefore, the solution will be x of t, where the C1 we put 0. So we'll have 0 e raised power 3t into 1, 3 plus 1 times e raised power 2t into this other vector is 1, 2. Now you see 0 times everything here cancels out to 0. So this will be 0 because of this 0 here. So just have e raised power 2t into 1 times 2, which is x of t, is e raised power 2t, 2 e raised 2t. And remember, in our notation, when we write x of t given by this, the first row of the first line is the function, the second row is the derivative of the function. So therefore, the solution to the initial value problem is x of t is given by e raised power 2t. What you have here is the derivative of the solution to that problem. Thank you.